Good evening. CPR Environmental Education Centre, Chennai welcomes you to our ongoing program, Our Environment, Our Lifeline. Today, the topic is rainwater harvesting. Groundwater. There is more groundwater than surface water. Groundwater is less expensive and a good economic resource. Groundwater is sustainable and is a reliable source of water supply. Groundwater is relatively less vulnerable to pollution. Groundwater is universally available. Facts. Fresh water, once considered an inexhaustible resource, is now fast becoming a rare and scarce commodity. India uses only 10 to 20% of its annual rainfall of 400 million hectare meters. When it rains, only a fraction of the water percolates and reaches the groundwater aquifers. The increasing numbers and depth of borewells and open wells under unrestricted use threaten India's groundwater resources. Lack of adequate storage facilities also result in wastage. Artificial recharging. The problem of groundwater depletion can be best tackled by harnessing every drop of rainwater. Artificial recharging to augment groundwater resources has become a necessity. We should therefore develop and popularize some cost-effective rainwater harvesting methods in urban and rural areas. Rainwater harvesting. Rainwater harvesting means making use of each and every drop of rainwater to recharge and replenish the groundwater aquifer, go into the well or under the ground. The main objectives of rainwater harvesting are to conserve the surface runoff during monsoon, recharge the aquifers, and increase availability of groundwater, improve the quality of groundwater, overcome the problem of flooding and stagnation of water during monsoon, prevent salt water intrusion. Various methods are available to recharge the water table by increasing the rate of infiltration. Artificial recharge can be achieved by obstructing the flow of water, storing the water, spreading the water through soak pits, by replenishing groundwater through wells and bore wells. The following are some methods used to recharge the groundwater: pebble bed method, percolation pits, recharge wells, ridges and furrows, check dams, gully control stone wall structures, contour bunding, trenching, land flooding. Rainwater harvesting by service wells, rooftop collection, to brick filter to service well. Rainwater harvesting through percolation trenches, percolation pit to percolation trenches. Rainwater harvesting through pebble beds, size of recharge pit, breadth 0.5 to 1 meter, depth 1 meter to 1.5 meter. Rainwater harvesting through recharge well, rooftop collection, sand filter, collection tank and recharge well. Recharging water through soak pits. Recharging groundwater by pebble beds. Size of recharge pit, breadth 0.5 to 1 meter, depth 1 meter to 1.5 meters. Rainwater harvesting through watershed management, stone walls and collecting in check dam. Traditional water harvesting through lakes and tanks. Other methods of rainwater harvesting. Runoff should be diverted into suitable designed structures near pavements, parking lots, parks, playground, etc. Rainwater can also be stored in underground storage tanks, water sumps for a few months and used directly for washing, flushing and other domestic purposes. Industries, multi-storied buildings, various offices, etc. can implement this cost-effective method as they depend mostly on groundwater for their needs. How much water can be harvested? Consider a building with a flat terrace area of 100 square meters. The average annual rainfall in Chennai is approximately 1100 millimeters or 44 inches. In simple terms, this means in 1 year, the rainwater harvested from the terrace will be area of flat is 100 square meters. Height of rainfall is 1.1 meters or 1100 millimeters or 44 inches. Volume of rainfall over the flat is equal to area of flat into height of rainfall, that is 100 square meters into 1.1 meters, that is equal to 1,10,000 liters. Assuming that only 60% of the total rainfall is effectively harvested, the volume of rainwater harvested is 66,000 liters. This volume is about 4 times the annual drinking water requirement of a 5-member family. Improving water quality by rainwater harvesting. In urban areas, CPR Environmental Education Centre has installed a huge rainwater harvesting system within the CPR Environmental Education Centre campus at Chennai. 24 recharge bore pits, 4 infiltration trenches. The recharge bore bits are about 20 feet deep and filled with pebbles. Percolation pits. Percolation pits of size 1 meter by 1 meter by 3 meter may be dug a little away from the building. The pit is then filled with brick jelly or pebbles, followed by river sand for better percolation. The top layer of sand may be cleaned and replaced once in 2 years to remove the settled silt for improving percolation. The trenches are 40 feet long and 3 feet wide. The depth of the trench is 4.5 feet. Each trench has 5 11 feet deep bore pits. The pits are filled with pebbles and the trenches are covered with a metallic mesh. Harvested rainwater has led to increased underground water availability. A dry borewell has begun yielding water again. No water shortage even during hot summer months. Role model for harvesting rainwater. In rural areas, improving water quality by rainwater harvesting. Nenmeli is a small village near Chengalpattu, 70 kilometers from Chennai and 40 kilometers from Kanchipuram. On the northern side of the village lies a small hillock called Mukkamalai. There are 2 ponds in the village. Washerman's pond, used for washing clothes and other cleaning and for bathing animals. Lotus pond, used for storing drinking water. But the village still lacked water. Why? During the rains, there used to be heavy soil runoff and erosion of topsoil, which would fill up the ponds and lakes. Thus, the rainwater could not be collected in the ponds. People of Nemmeli approached CPR Environmental Education Centre for a solution. Nemmeli before watershed management in the below photograph. In 1995, CPR Environmental Education Centre took up watershed management and afforestation activities. Watershed development was carried out by contour mapping and bunding, gully plugging, stone check wall, etc. Pits were dug for plantation and mulched, and the site was completely fenced. Biofencing of the entire site was then undertaken. Contour trenches to collect water and increase the infiltration rate were dug in the ground at the foot of the hill. Contour stone walls were constructed. A small percolation pond was constructed. Watershed management undertaken by CPR Environmental Education Centre has helped fill the surrounding ponds and tanks and also raise the level of groundwater from a depth of 30 feet to almost ground level. The entire area has become green. The runoff of rainwater and subsequent soil erosion has ceased. The average canopy height of the trees is about 10 meters. The well is full of water. The water becomes more tasty due to reduction of total dissolved solids. Harvesting and conserving water is every individual's duty. Every drop of rainwater is precious. Save it. It might be the very drop that will quench your thirst one day. Rainwater harvesting for a better tomorrow. Please write your suggestions and feedback to our official email ID cpreec@gmail.com. Kindly subscribe us on YouTube CPR EEC Chennai to get notifications. To join the next meeting, link will be shared shortly to your email ID and WhatsApp. Welcome back, participants. For the remaining time, this session is open. Please unmute yourselves. You can talk to us. Since there are no questions from your side, we are ending the session for today. Thank you all for your participation.